Question number 13. Sketch the graph. This is a quadratic equation, clearly indicating the intercepts on both axes, that means the x-axis and the y-axis, and the coordinate of the turning point. Now, I'm going to take you to two places. Now, this is actually a good preparation for AS level, and I think it's also a more difficult question to handle, but it's not, you have all the knowledge to handle a question like this. Okay, so let's just start, and I'm first going to take you to the textbook and show you where you will get information. On page 249, this is question number 13. Okay, before this is the turning point. So before I go to the turning point, I think I would like first to just show you how to find where it cuts the x-axis, where it cuts the y-axis. And I want us to use not a table, because this is not a graph in the sense it's not on graph paper. So we want a specific value. I want to use this method that we use a lot in linear programming. So it's on page 321. I'm showing you this, and it's chapter 7. So if I ask you to draw a line, any line, draw the Cartesian and shade the unwanted. If you want to see, it doesn't matter if it's a straight line or a quadratic equation or a log equation. If you want to see where that line, that graph, cuts the x-axis, you make y0. And if you want to see where it cuts the y-axis, you make x0. And that's what I'm going to do first. I'm first going to find where it cuts the x-axis and where it cuts the y-axis. Okay, so let's start. So my equation is y is equal to 2x squared minus 5x minus 3. So where it intersects or cuts the x-axis, you make the opposite, y0. And where it cuts the y-axis, I can actually already see it, but I'll show you now. You make x0. Because I can already see it cuts the y-axis there at -3, but I'll show you in the calculation. So, in this case, I'm going to put a 0 in the place of y, and then it's a quadratic equation. And I'm going to first see, and usually if it's like this, not on graph paper, it would be able to factorize. Otherwise, you can go for the formula. So in this case, you know my groups, I factorize. So I will say it's in group B. So if I look for my factors, I'm going to look so that if I cross multiply and I subtract that red, then I must get 5. So 6 minus 1, that's 5. Then I will say the biggest over cross product, and that's the biggest over cross product, will take the middle sign because the signs will be different. And then the other one will be a positive, and it's x. So if I factorize it, I'm going to get, let me just write it nice. I'm going to get 2x plus 1 and x minus 3. So if I put that brackets equal to 0, I'm going to get that this 2x is -1. So x is -1/2. Okay, you're having that. -1/2. It cuts the x-axis at -1/2, and it cuts the x-axis, take that word, at 3. Now, if I take that equation again, and in the place of x, I put a 0. Then I get 3. So it's cutting the y-axis at 3. So I already can go. Now, please, just take a ruler. Now, I'm going to see if I can, because now I didn't have a ruler here. But let's see if I find my applications. There's my applications. And I'm going to just take that ruler to help me. Okay. That ruler is going to help me to quickly just mark that. Okay, let's just move it down. Oh, I'm moving the whole page down and not just the ruler. Okay, I want just the ruler down. Okay, so take a ruler, there I showed you, and just at least make 1 centimeter blocks. It must be a little bit on scale. So every time I put it, doesn't matter. I'm just showing 1 centimeter. Okay, it's not to say that it's going to be count 1 unit. I will check at the end to see what it will count. Okay, and then I can take that ruler again, and I can just turn it. Come on, turn. Okay, and move back. And as I said, I'm just trying to get my 1. I can just, because the ruler was there, I was struggling a little bit to put it through. Okay, so just make that through. Okay, it's again all right. It's on 8 there, so I can just mark, just that you have at least equal spaces. Okay, now I think I'm first going to get all the points, and then I'll decide on the scale. So ruler, thank you. You helped me a lot. I think I can say goodbye to you now. Okay. Now let's just see. Where do I say goodbye to you? I think there. Okay. So, okay. I know already it's cutting the x-axis there and it's cutting the y-axis there. Now I want to take you to that page. So in the textbook, I want to take you to how to find the turning point. And that is question 13. Okay, and if I must show you in the textbook, it's on page 249, and that will be in chapter 6. And it's to write it in this form, because as soon as you write it in this form, then you can find the turning point. Okay, now can you remember, it's like completing the square, but you just do it with the expression. So if there's a number in front, then luckily, yes, this is a 2. Then I will take 2 out as a common factor. And then I just leave that space. Can you recall? And then I take that middle term there and I divide it by 2 and I square. And I just want to use color to show you. So, okay, so that was the original ones. That. But then I take the middle term and I divide 2 and I square. And because it's an expression, whatever I add, I must subtract. And that's what I did there. And then I'm just going to simplify this now. Now, remember there, I created a complete square. 2 brackets with the same sign. 2 brackets, which is exactly copy and paste. Okay, and I take the square root, that sign, square root, and that's 2. So that's that bracket. But then I just take my calculator and I just simplify that. So that's 4 minus 4, and that's 0. Now, from that, I can find my turning point. So this P, can you check there? That's going to be the x value, but you change the sign. So if it's negative 2, it's going to be positive 2. Do you see there? And then Q, in this case, Q is 0, so it's 0. You take that value as it stands there, and there is your turning point. And then, according to this, can I just show you there? According to, if it's positive there, then it will look like this. It will have a minimum point. And if it's negative, it will have a maximum point. Okay. So this was extra quadratic. Go back to and complete the turnings. So very good practice there on page 249. Okay, but let's go back and let's do that question now. Now we have all the info to do that question. Okay. So let's find. Now if you don't want to write in the sketch, remember this is also space. So I'm going to find the turning point now. But first I'm going to write it like this. Okay. And now if I'm going to get that turning point, I'm just going to work with this expression. So I'm going to take out 2 as a common factor. It's not the equation, it's the expression now. So x squared minus 5 over 2x. I leave a space, negative 3 over 2, because if I take it out, I must divide it with the common factor in front. And space and close. Okay. Then I'm just going to say 2. Okay. And now I'm going to complete. I'm making it a perfect square. 2 brackets, that's the same. So I'm taking this middle term, which is negative 5 over 2. Color is not good. negative 5 over 2. I divide it by 2, 2 over 1. So it's actually negative 5 over 2 multiply 1 over 2, which is negative 5 over 4. And I square that. So I add negative 5 over 4. Now, it's not necessary that this negative, it will become positive, but let's rather leave it like that. Negative 5 over 4 square. So whatever I add, I must subtract again. Now, I'm sitting with, I can actually already go for my middle because I created already my middle. So I take the square root, and that's x. That sign I write there. I take the square root, and this is going to be 5 over 4. And there's my square. And now I take your calculator and simplify that. Then it's not so difficult. So on your calculator, press negative 3 ABC, you know that fraction key, 2. You can even put everything. So minus bracket, minus 5 ABC, 4, close the bracket, square equals. And I get negative 3 and 1 over 16. Okay, but now I want to get this 2 in front, and I must multiply this 2 with this. So it's going to, it must be like this. I actually multiply this 2 in, but just here in front, and then that one with that one. So 2x minus 5 over 4, there's my square. Okay, so you have that negative 3 and 1 over 16 on your calculator. So just multiply 2. And I get negative 6 and 1 over 8. Okay, so what is my turning point? My turning point is going to be, I change this sign. So if I change that sign, it's going to be positive 5 over 4. And it's going to be negative 6 and 1. I prefer that you rather write it as mixed. It's easier to plot. So it's 1 1/4 and negative 6 and 1 over 8. And it was actually a bit, so that's why it's a sketch, not accurate. Okay, so now if I look at this, I see that this graph actually comes so 1, 2, 3, 4 will not work. And this is why I first get all my points before I decide. So what I'm going to do is I can work in twos. So negative 2, negative 4, negative 6, negative 8. I think that will work. And then it must be 2, 4, 6, 8. For this one, if I look at the x values, I'm fine. The x I can go 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Now, they're not strict on that, but that is the x-axis. I don't think they're so strict, but it's not about what is correct in the exam. It's about what is mathematically correct. Okay, so get used to writing good maths. Y-axis. Okay, I'm going to plot. So if I plot the points, okay. So first where it cuts the x-axis. So remember, it's negative a half and 0, and this is 3 and 0. So now they want you to indicate it. So they want you to write there negative a half, because there is the point. Okay. Then, so please just indicate. Don't just mark it. Write negative a half. And then 3, luckily 3 is already indicated there. So they want to see that 3 also. Okay. It cuts the y-axis at, it's got negative 3. Oh, let's just see. Yes, sorry, I forgot the negative. There, do you see? Negative 3. So again, if you plot that point, it's there, but you must write negative 3. Don't leave it out. So that's also a point. And then comes the turning point. Now the turning point was now that 1 1/4, remember, I'm going to rewrite it here. So the turning point was 1 1/4 and negative 6 and 1 over 8. So 1, there is 1, okay, and 1/4. So it's just, there's the half, and there it's 1 1/4, so there. And then negative 6, I go down, 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 down. Negative 6 and 1 over 8. It's a little bit closer to the 6. I just want to see. So it's almost like that. Okay. So can I just write it? You must write it. So it's 1 1/4 a -6 and 1 over 8. You must indicate the point there. Then you can just basically take your free hand and you're just going to make a nice parabole for them. And then this side will just repeat to this side. And to be really nice, that was not so nice. Then I take the incorrect. Bit more difficult technology, but I'm going to succeed. Okay, I think you can draw a better curve than I did here with my technology. And then for me, as I said, mathematically, let's do everything correct. So we're going to write the name y equals 2x squared minus 5x minus 3. And that is, so make sure they want to see that you mark that. Can I show? They want to see the 3, they want to see the -12, they want to see the -3, and they want to see the turning point. It's a level 3 question. It's more difficult. It's a very good preparation for AS level. And it's 5 marks. And where will you get that marks? So can I just read for you? You will get 1 mark. So it's very good. Just by getting these points, it seems to me, if they saw you have x3 and x, you already get, even if you cannot draw. And if you in the y, so already 3 out of 5. So the turning point was basically then just the last one and then the curve. So really, it's not that difficult. Okay. But I think they wanted you to mark it on the graph. So just at least mark that points that you got already on the graph. And even if your turning point was not there, then you can draw through that points. And then you can at least score that 3 points. Okay. And that was question number 13. Question number 14. 2 unbased dice are thrown. Okay. That means just it's perfect and it doesn't, it's the correct way, so it can fall any side. The difference between the scores obtained on each die is then recorded in the table. Complete the table, and this is very important, complete the table showing the values of the differences between the scores. Now, usually, sometimes you will just mark what you need, but now they want you to find the difference. So they want you to take the big one's number and subtract the small number. So 1 minus 1 is 0. 2 minus 1 is 1. 3 minus 1 is 2. 4 minus 1 is 3. 5 minus 1 is 4. 6 minus 1 is 5. Then you big one minus small one. So 2 minus 1, that's going to be 1. 0. 3 minus 2, 1. 4 minus 2, 2. 5 minus 2, 3. 6 minus 2, 4. And then 3 minus 1, 2. 3 minus 2, 1. 3 minus 3, 0. 4 minus 3, 1. 5 minus 3, 2. 6 minus 3, 3. So make sure you don't make mistakes. 4 minus 1, 3, because they are different. It's actually to help you. So 4 minus 2, 2. I'll show you now why. 4 minus 3, 1. 4 minus 4, 0. 5 minus 4, 1. 6 minus 4, 2. 5 minus 1, 4. 5 minus 2, 3. 5 minus 3, 2. 5 minus 4, 1. 5 minus 4, 0. 6 minus 5, 1. 6 minus 1, 5. 6 minus 2, 4. 6 minus 3, 3. 6 minus 4, 2. 6 minus 5, 1. 6 minus 6, 0. I just want to let you see there's a pattern. Do you see all the zeros? And there will usually be patterns. Okay, so do you see the zeros? Do you see the ones, the twos, the threes, the 4? It's actually also easy if you don't see out of the pattern just to control that one. Then basically again. Okay, so let's start. Now first they say complete the table. Yes. Give your answer as common fractions. That mean a top and a bottom in their simplest form. So they want you to simplify. Usually it's not necessary in probability, but check. If the questions specify it, then do it. Calculate the probability that the difference is equal to 0. So now you can go and say, how many zeros are there? And I like to make a circle. Take a pencil. then you're not going to disturb too much. Okay, so the probability of 0 is going to be 1, 2, 3, 4, 5, 6. But it's 6. And how many are there? 6 times 6 is 36. How many blocks? But they said simplest form. So if you don't write 1 over 6, they're going to penalize you. Okay, so 1 over 6. That the difference is equal to 1. Okay, now 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the probability difference 1, and that's 10 out of 36. And again, simplify. Press it on your calculator otherwise. Say 10 ABC 36. Your calculator will say 5 over 18. Okay, because they said simplest form. And now this is something, and I think it's due to the language, that a lot of us, the home language is not English, and then it's not coming so naturally. They say that the difference is less than 2. Okay, so if they say less than 2, it means it can be 0, or can be 1. Okay, so 0 or 1. Now, actually, they test. You already have the zeros and you have the ones. Do you agree? So, basically, it's just this. You can go and add up. It's actually the green and the red. But it's actually that 6 zeros plus the 10 ones, which will give you 16 out of 36. And if you simplify it, 4 out of 9. But if you go and you add, just press on your calculator, 1 ABC 6. Take this number and add 5 ABC 18, because it's that 2. Then you will also get 4 out of 9. Okay, that is not that difficult. Okay, but again, it's also a topic like trigonometry, probability, statistics. Spend more time on that topics towards, especially in your grade 11 year. Okay, let's just go to the next one, number B. Now, number B is a bit more difficult. But again, it's not that. And they gave you the tree, and it's going to help you a lot. Okay. So, in this case, they say a baker has 6 eggs in the fridge. 2 of them are bad. Now, how many is good then? 4. He picked 3 of the eggs at random. Complete the tree to show the probability that baker picked 3 eggs at random without replacement. Now, just remember, and I think I said it in a few question papers already. I will take you now to one. But before I'm going to take you to an example, let me first take you to the example. It's like I don't have to write so many things if I can just take you quickly to the textbook. So this is question number 14b. Okay. Now, if they said he picked at the eggs, okay, baker 6 bad. He picked 3 of the eggs at random. Complete the tree, show that the baker picking eggs at random without replacement. That means dependent. So if there was 6 eggs and he take 1, then there's 5. If you take another one, then there's 4. And you can see it already from the graph. And this is why I'm using this example. On page 648, it's in book 2. And example 16, probability. So Gerard has 8 sweets in a bag. 4 sweets are orange flavor, 3 are lemon, and 1 are strawberry. Okay, so there's 3 options. There is just 2. Why I'm showing you this is just to show you that if, and this is very important, that this, if you add this, that fractions, you must always get 1. Because that's the certainty. If you add that 3, you must get 1. If you add that 3, you get 1. If you add that 3, you get 1. Because that's going to help you. And then if we come to the question, so that's help. Oh, and if they go on. So if they take a lemon again, and a lemon again. So there was 3. Then now there's 2 out of 7. That was 3 out of 8. 7. And then 1 out of 6. So the denominators become 1 less, and because it's a lemon every time, then the numerators also become 1 less. And then I said to you also, if they say now, The two sweets have different flavors. As soon as you come to, so different, the same flavor. Okay, I first took the same flavor because this is one that we. So if I work in a branch, I multiply. Okay, so I'm first taking the same. They ask for different. I'll show you now. And I multiply. And then I multiply. And okay. Now, if I want the result of all this, I add. Now, different flavors is the ones that's left. It's not the yellow ones. It's actually this one, this one, this one, this one, this one. That's the different flavors. Now, you can either just also multiply the greens and then add all the greens together. Okay. Or if you add all the green branches and the yellow branches, you must also get one. So that's why when I wanted to find that one, I just took the whole tree. That one was representing the whole tree. And I just subtracted to find I just subtracted that yellow ones, which was 9 over. And then I was left with the green ones. Okay, that's just a few basic things that I wanted to show you. And now I can tackle that graph on page 648. So let's go back to the question paper. Where is that? It's question number B. Oh, it's just question paper again. Okay. There it is. Okay. Now I can start filling in. So he's having 6 eggs. So it's going to be 6 out of 6. 2 of them are bad. Okay, so let's just get the tree a little bit upper. I'm making it a bit smaller that you can see better. Okay. So if I say, and I start here, 2 of them are bad. So bad is 2 out of 6. There's the bad. So good is 4 out of 6. That was the original. Then he picked 1. So if he pick 1, everyone will now be 5. And can you see the rest is already? For this one, you're going to assume he took a good one. So there's now just 3 good ones. Okay. For this one, you're going to assume he took a bad one. So if it was 2, then it's 1. But you can test it by saying 3, this 3, plus this 2 is 5 out of 5. Because I said to you, these 2 arms must add up to 1. The same, 4 out of 5, then this must be 1 out of 5. Okay. And actually, if you look at this, except for this one, you can fill all of them in. But let's rather go through that with the tree. So if we go for the first, so now there's not 5, there was 5. But now if you take another one, there's just 4. And then it was a good, another good, and now there's just 2 good. And they were catching you out a little bit there by saying a half, but it's fine. If you wrote a half, that is also correct. Okay. So half plus half is again 1. Now, this ones you could have just filled in. If this is 3 over 4, you don't even have to think. You just make it that it's 4 over 4. That one, can you test? 3 plus 1, it's 4 over 4. Excellent. This one is usually, again, it's almost like the top ones is easy and the bottom one. The in-between is a bit thinking. Okay. So, now, it was 6. Then it took two bad. And then there was 1 bad. And then this is 4. But there was just 1 left. So there was no bad one left. So meaning everything was good, which would have been 4 out of 4. Okay. And they are saying that you would have get marks. And let's just check where you would have got the marks. I just want to see B1. Oh, B1 for any 2 correct. Okay. But there was 4. If everything is correct, you could have scored 4 marks there. So make sure you can complete the trees. Okay, and then I go to the next one. Find the probability, and now here comes the English again, that at least 2 of the eggs are bad. Okay, now what does mean? Okay, it's almost the same. To pass mathematics at the end of grade 11, you must at least get 40%. Does it mean you must get 40 lower, or does it mean 40 and higher? So although the word say least, it means you must get 40% or higher. So if I come back to the eggs, then it means there are free draws. So that means in that draws, it must be at least, so it means it must be, and let me say, 2 bad or 3 bad. So if I go in this line, in this branches, I must find either 2 bad or 3. Now, if I'm going to draw that branches for you, let's just go through the different branches. This is good, good, good. There's just one, at least 2. So this is good, bad, good. No, can I draw that? There is one, because there's 2 out of the 3. So you will. Okay, let me just get my pen. No, I want my highlighter. Okay, so good, bad, bad. Do you see that? 2 bad. Now, let's find another one. So it's bad, good, good. There's only 1 bad. There must at least be 2 or 3. So bad, good, bad. You're going to work. So bad, bad, good, bad. So I first just find the branches. Then this one, let's just see. Bad, bad, good. You're also going to work. So bad, bad, because there's 2. And then the last one, because that's bad, bad, bad. So it means either 2 or 3. At least means either 2 or 3, not 1. So it means then this one will be bad, bad, bad. So basically what I'm going to do now, I'm going to take this values, which I can show you here. I'm going to multiply it. So in the branches, I multiply. And then at the end, I'm just going to take all the green ones and I'm going to add it. So let's start. Let's start with this one, writing it down. Now just make space. There's not so many space. Okay. So I'm going to say there is 4/6 multiply 2/5 multiply 1/4 plus, that was that one. Now this one, 2/6 multiply 4/5 multiply 1/4 plus, and now I am at this one, 2/6 multiply 1/5 multiply 4/, where am I? I'm at the third one. So it's 2/6 multiply 4/5 multiply 1/4. And then the last one, I'm just going to, I just have to continue here. So it's going to be 2/6, this one, multiply 1/5 multiply 0/4. And I can see that this one will become 0. So if I multiply this 2, what do I get? 1/15. Okay, take your calculator, go and press. Say 4ABC6 multiply 2ABC5 multiply 1ABC4, and I get 1/15. Okay, that's the easiest. Do the same with this one. What do you get? Now, if you look at the values, it's now just go 2ABC6 multiply 4ABC5 multiply 1ABC4, and I also get 1/15. Okay, let's see this one. 2ABC6 multiply 1ABC5 multiply 1ABC4 equals, here I made a mistake, 2/6, 1/5, here is my mistake. It's 4/4. It's this one. Do you see? So it's 2/6, 1/5, 4/4. Okay. So it's 2ABC6 multiply 1ABC5 multiply 4, ABC 4 equals, and it's 1 over 15. And then this one, as soon as you 0, it's 0. So what will I get? I will get 3 over 15. But because if I simplify it, then the probability will be 1 over 5. But I think they took this as correct. They took this also as correct. Okay, so then they say that what did they give a mark for? If you were just taking this, if you said 1 minus that one, so let's just see, 3 over 5. Oh, if you were just taking the free, so 1 mark if you only had the 3 branches and not all of them. Okay, then 1, 2, 3, then you would have get 1 mark. Okay, and then the last one, find the probability that the baker picks at least 1 bad egg. And it's again that word at least. I don't like the word also. At least 1 bad egg. So it means it can be 1, it can be 2, it can be 3. So if you look at the branches, can I just show you? There is a bad, there is a bad, there is a bad, there is a bad, there is, so it can be 1, 2 or 3. There is a bad. The only one that's not having a bad in is, and can I show you, is this one, the good. And now, because I know all the branches add up to 1, I'm going to make use of that principle. So I'm just going to say, okay, I want all the branches except the red one. So I'm just going to say 1, let's just get my pen, 1 minus, and I'm just taking the good. So it's 4 out of 6, multiply 3 out of 5, multiply 2 out of 4, and that's 1 minus 1 over 5 if you multiply that, and that will give you 4 out of 5. Okay, and that was the final answer. So if you come and you were subtracting and you realize that it was everything except the red, and that was the red, then they gave you 1, and then for your final answer. Now this is a bit concentration, and at least if they bring in words like at least and this, so just, we did it also in linear programming when we did shading, using that, and either go on tables if you struggle with that, at least, at the most. I just want to see, because I know in linear programming, and I want to see if I gave you a table. Yes, on page 330. So if you struggle a little bit with that, at least, that words. So on page 330, I gave you a table. What is it? At most 10, at least 10, a minimum of 10, a maximum of 10, not less than. I gave you a table. And if you really struggle a little bit, try memorize it, that it helps you.